let's go over complex numbers, and the first one we've been given here is that if 1 plus 4 square root of 3i is equal to a plus ib squared, prove that a squared minus b squared is equal to 1, and also ab is equal to 2 square root of 3. So to prove this one, the first thing we are going to expand these brackets here. So this is 1 plus 4 square root of 3i, and this is going to be equal to, when we expand these brackets, we get the a, we square it. We get this to multiply by this, we also multiply by the 2. So that is going to be 2 abi, and then we are going to get the a ib square it also. If you want, you can write these 2 times and then you start crossing and multiplying. That will be 1 plus 4 square root of 3i being equal to a squared plus 2abi. If we square the I, that is going to give us I squared, which is equal to negative 1. So this is going to be negative. And then we square the b, that will just be b squared. So a squared and b squared, they don't have any I. Those are real parts, so we're going to put them together. That would be a squared minus b squared, and then we're going to write the 2abi also alone. So you compare the real parts and the imaginary parts on both sides of the equation. So inside 1 is going to be equal to a squared minus b squared the other side, and then here this part which contains an I, the 4 square root of 3 is going to be equal to 2ab. We'll divide both sides by a 2, that will be 2 square root of 3, that is going to be ab. We can see that this is what we've been given there, and this is this one, so shown. And then the next one here saying simplify the following: I to the power 7, I to the power negative 3, I to the power 9. So before we get to simplify this one, we need to know that I squared is equal to what? Negative 1. That is because I is equal to square root of negative 1. So if I multiply this I squared by I, that will be I to the power 3. And if I multiply negative I, negative 1 by I, remember I'm multiplying by I both sides, that would be negative I. Then multiply again this one by I, that would be I to the power 4. Multiply this one also by I, that would be negative I squared, and we know that I squared is what? Negative 1, so it will be negative 1 times negative 1, which is positive 1. Multiply again by I, this will be I to the power 5, 1 by I, that will just be I. Multiply again by I, that will be I to the power 6, I to the power 6 times, I mean, that will be I to the power 6, and then also this one multiplied by I, that will be I squared, and we know that I squared is negative 1. Multiply again by I, that will be I power 7. And also the other side, negative 1 times I, that will be negative I. Multiply again by I, that will be I to the power 8. Then negative I times I, that will be negative I squared, and we know that negative I squared, where there is I squared, we're going to put what? We're going to put negative 1, so that will be positive 1. And then I to the power 8 times I, that will be I to the power 9. And then 1 times I again, that is going to be I. And then I to the power 9 times I, that will be I power 10. Then I times another I, that is going to be I squared, which is negative 1. So from here we can see a common trend. We can even deduce an equation for this operation. So we can now work it out. So we can see that I to the power 7 is the same as what? Is the same as negative I. So that's the simplest form. And then if we go to I to the power negative 3, how are we able to get that? So we can deduce an equation just from here. We can see that if we have got I to the power 2, we are going to have negative 1. What else is giving us negative 1? Apart from this one, we have got this one and this one. So what's the difference? So from I to the power 2, we can see that that is also equal to I to the power 6, and that is equal to I to the power 10. So what is happening in this trend, you are able to see. So if we have got a 2, you are adding what? You are adding a 4. You are adding a 4 like that. So this means that I to the power 4n, okay, is going to give you negative 1. Every time you have got this, it always gives you negative 1. And then the next one, you can go to those which have got an negative I. We have got this one, we have got this one. So what is happening? We have got I to the power 3, and that is also equal to I to the power 7. So what is happening in this trend? When you've got I to the power 3, for you to get 7, what is happening? So we can see if I can say this is going to be, we have got a 3, we are going to multiply it by n, and then we are going to add a 4. So if n is 0, n is representing a positive integer. If n is 0, okay, we are not going to add a 4, but we are going to add a 3. So this is supposed to be 4n plus a 3 instead of me writing 3n plus 4. The reason for this is if n is 0, this is going to be 0. 0 plus a 3, that is I to the power what? I to the power 3. And you know that I to the power 3 is giving us what? Negative I. If n is 1, we're going to put 1 there. 4 times 1 is 1. 4 times 1 is 4 plus 3, that is 7. And you know that I to the power 7 is still giving us what? Negative I. We can go to the next one. Let's say if we use a 2. That means 4 times 2 is going to be what? 8. And 8 plus 3 is going to give us 11. 11 is also going to have a negative I. Just like that. This is an equation that we can make also for this one. Okay, it's not only these two. We can also go to those which are giving us a 1. So we can see we have got this one. We also have this one. So we have got I to the power 4 and I to the power 8. So what is happening? And the next one is of course going to be I to the power 12. So from the trend that we're able to see here, let's hope I didn't use a different one for this one I derived here for 4n, which is giving us negative 1. This one wasn't supposed to give us a negative 1. I use this one which I've written here. For negative 1, we are seeing if we say 4n, 4 times 1 is 4. This is giving us what? I to the power 4 is giving us an I, a 1 I mean. And then if we put a 2 here, 4 times 2, that is going to be 8. That is still giving us a 1. If we put a 3, so this was supposed to be a 1, not negative 1. And then for negative 1 is the one now we are getting here. Let me just write this again so that you'll be able to follow, since I wrote something before that can confuse us. So the equations which we are getting here, starting with those which are giving us a negative 1, we've got this one, we've got this one, we've got this one. We have got I to the power 2, I to the power 6, and I to the power 10. So what trend are we able to see here? So we are saying we are adding a what? We are adding a 4. So we can write a general equation that I to the power 2 plus 4n. Okay, we are adding a 4. And then these 4s can be different. That's why we're putting this n. Meaning that if n is 0, this will just be I to the power 2. If n is 1, this is going to be I to the power 6. If n is 2, this is going to be I to the power 10. And this equation is always giving us what? A negative 1. And then we'll come to this one, giving us a negative I. We have got this one and this one. So I've got I to the power 3 and also I to the power 7. So what is happening here? When you've got I to the power 3, we are adding a 4 for us to get 7. So we're going to add a 4n because it will continue going in that will be the trend. And this will always give us a negative I. This is another equation or a general expression that we can work with. And then we can go to those which are giving us a 1. We have got 4, we have got 8. So I to the power 4 is equal to I to the power 8. What is happening for me to move from 4 to 8? I'm just multiplying 4 by what? By a 2. Or I'm adding a 4 to 4. So I can just say this is going to be I to the power 4 plus 4n. Or I can say I to the power 4n just without saying 4 plus 4n. This is going to be the same. Why? This means that for this one we're going to be starting from 0. Like if n is 0 here, then it's going to be 0 plus 4, that is going to be 4. And this is always going to give us, we can say it's always going to give us a 1. But if we are dealing with this one, then the smallest number for n we should have, which is going to give us the same result as this one should be a 1. For example, if this is a 1, n is a 1, if we're using this equation, then when we're using this equation, we should use n to be a 0. So any one of these we use is going to give us the same one. So this is a general trend we are seeing. Now, the I to the power negative 3 that you've been given, of course, we have also those which are giving us what? An I. We have got I to the power 5 and I to the power 9. This is always equal to an I. Now, we can write the general expression. You can see that if we have got I to the power 5, we're just going to add the 4n. This is always going to be an I. So to be able to see this one, we are going to compare these three. We are going to equate the three to one of these powers, either this one, this one, this one, or this one, which is here. The one which gives us a whole number is the one which is going to be the answer. So we're going to say I to the power negative 3 is equal to, I can start with, let me write this one which is here, is equal to I to the power 5 plus 4n. So since the i's are the same, I'm also going to equate the powers. So this is going to be negative 3 plus 5. Negative 3 is equal to 5 plus 4n. I'm going to take 5 the other side. It is going to be negative 5. So negative 3 minus 5, that's going to be negative 8, and that is going to be 4n. Divide both sides by 4. N is going to give us a negative 2. So this is an integer. N should always be an integer. Then that means that I to the power negative 3 is the same as I to the power 5 plus 4n, and that we know is equal to what? Is equal to an I. So this is going to be an I. If you tried all of these others, it wouldn't work out. It is going to fail. The reason it's going to fail is because it's not the same. For example, if we try this one which is here, we compare negative 3, we equate the powers. Negative 3 we equate to this power which is 3 plus 4n. I'm going to take 3, the other side is going to be negative, so it should be negative 6 is equal to 4n. And 4 can't go into negative 6, we're going to get a fraction. And every time you get a fraction that's not an integer, then that's not going to work out. Now we can look at C, which is I to the power 9. Now, which one are we going to use? The equations we need to know is that I to the power 4n plus 2 is equal to negative 1. We've already derived this. I to the power 4n plus 3 is equal to negative I. Then we've got I to the power 4n plus 4, or simply I to the power 4n. This is always going to be equal to a 1. And then we have got I to the power 4n plus 5. This is always going to be equal to an I. So here we are. So which ones are we going to compare to? So if I get to equate the 9 with this power which is here, let's try. We see what we're going to get. 9 is equal to 4n plus 2. I'll take to the other side to be negative 9 minus 2. That is going to give us a 7, and 7 is equal to 4n. If we divide both sides by 4, we are not going to get a whole number. It is going to give us a fraction, so that means it can't work. So I'm going to try to use, let's use this one. 9 is equal to 4n plus 5. Take 5 the other side. It will be equal to 9. So if it goes, it becomes negative. That will be 9 minus 5, which is 4, and that will be equal to 4n. Divide both sides, we are going to find that n is equal to 1. It's a whole number. That means I to the power 9 is equal to what? What have we used? We've used this one. I to the power 9 is equal to an I. And then for D, we have got I to the power 105. So which one are we going to use? So same, I to the power 105. Let's try to use this one. So we say 105 is equal to, we are just comparing the powers, is equal to 4n plus 5. Take 5 this side to be 105 minus 5, which is 100, and that is going to be 4n. So divide both sides by 4, n is going to be 25. So we see this is an integer. So that means I to the power 105 is the same as I to the power 4n plus 5, which is equal to I. And then the last one here, we have got I to the power 4n. Now we've already derived the equation. I to the power 4n, we know that is equal to a1. And then we have got I to the power 4n plus 1. What is it going to give us? Now if we say, let's say an n is less than 0, that means we're going to have I to the power 1. And we know I to the power 1 is simply what? A negative 1. Okay, now let's start from n maybe being equal to 2, or n is being equal to 1. We say 4 times 1 is going to be 4 plus 1, that is going to give us a 5. So we have got I to the power 5. And then if we say n is 2, that will be 4 times 2, 8 plus 1, 9. That will be I to the power 9. And you know what this trend is? What equation is this following? It is following this one. 4n plus 5, it is the same as 4n plus 1. Also this one, we are going to have, if we use a 0 here, we are going to get power 5. If we use a 1 here, we are going to get power 9. If we get a 2, so the trend is the same. So this means that this one is always going to give us an I. I hope we are able to get that. Alright. We also have this one. The question is saying simplify I to the power 4n plus 1 minus I to the power 4n minus 1 divided by I, where n is a natural number. So what is this going to give us? So let's say n is a 1. That means we're going to have I to the power 5. If n is a 2, we are going to have I to the power 9. If n is a 3, to continue like that. And for this trend, we know that for this one, we are following the equation I to the power 5 plus 4n. And for this equation I to the power 5 plus 4, how did I tell it is I to the power 5 plus 4n? I'll just get the 5, which is the smallest. What number should I add to 5 for me to get 9? It is a 4. So you always add an n, because every time you add 4 to the next term, it will always give you the other term that proceeds. And this trend 5 to the power 4n, I mean I to the power 5 plus 4n, always gives you an I. So this means that this is an I. That is going to be I minus what of this trend? What is it following? So if I say I use a 1 here, that will be 4 minus 1, that will be I to the power 3. And if I use a 2 here, that will be 8 minus 1, which is a 7. And the trend we are following here is, if we have got I to the power 3, for us to get I to the power 7, we are adding a 4. So just say 4n. And this trend, we know it always gives us negative I. That means I to the power 4n minus 1 is equal to negative I. And then in the denominator I've got I. So I minus negative I, that is going to be 2I over I. So the i's are going to cancel out. This is just going to give us a 2. So that is it for this one. Express each of the following polynomials in I in the form a over b. And the first one we have is 3I to the power 7 minus 2I power 6 plus 5I power 5 plus 3I power 4 minus 8I power 3 plus 4I squared minus 6I minus 10. How can we simplify this one? We know that I to the power 7 is the same as negative I from the trend that we've been using. And then we know that I to the power 6 is the same as negative 1. And then we know that I to the power 5 is just I. And we know that I to the power 4, that is going to give us a 1. And we know that I to the power 3, that always gives us a negative I. And then we have got 4 I squared, we know that's negative 1. Okay, then we've got negative 6I minus 10. So this is going to give us negative 3I plus 2 plus 5I plus 3 minus, this is going to be plus 8I minus 4 minus 6I minus 10. So we add like terms. 2 plus 3, that's 5, minus 4, that's 1, minus 10, that's negative 9. Then negative 3i plus 5i, that is going to be positive 2i, plus 8i, that's 10i, minus 6, that is 4i. So that is going to be it for this one in the form a plus ib. And then the next one is 5i to the power 103 minus 4i to the power 102 plus 8i to the power 101 minus 6i to the power 96 plus 6i plus 18. So again, we need to know our general equations. When you have got I to the power 4n plus 2, this always gives you a negative 1. I to the power 4n plus 3, this is equal to negative I. Then I to the power 4n plus 4, this always gives us a 1. Then I to the power 4n plus 5, this always gives us an I. So if you talk of 103, in which of these forms can it be expressed? So I'm thinking it is in this form, because if we say we equate the powers 4n plus 3, we equate it to 103. I'll take 3 the other side, it becomes negative, so that will be 4n is equal to 100, and we know 4 can go into 100. So that means I to the power 105 is the same as negative I. It will be 5 negative I minus 4. Now 102, I need to use something that is going to remove a 2 from 102 for it to remain 100. We're going to remove this one, because if we say 102 is equal to 4n plus 2, 2 goes this side, it subtracts. 100 is equal to 4n, and we know 4 can go into what? 100. So that is giving us a negative 1. Then I've got plus 8. Now for this one, which one of these are we going to equate to? 101. So we're going to equate to this one. Why? If we say 101 is equal to 4n plus 5, we take 5 this side, is going to be 101 minus 5. That is going to give us, of course, 96. And 96 can be divided by 4. So you always look for something that can be divided by 4. So this is going to be equal to an I. And then minus 6. Now 96 is here. So what number below 96 can be divided by 4? That's a 92. So we need to make sure that this one remains as a 92. What number can we remove from it? We need to remove a 4. So we're going to use this one. You can try them out of these. So that's going to be a 1. And then I've got plus a 6i plus 18. So this is negative 5i plus 4 plus 8i minus 6 plus 6i plus 18. Then add like terms. 4 minus 6, that's negative 2, plus 18, that's a 16. And negative 5i plus 8i, that's a positive 3i plus 6i. Okay, so plus this 6i, that is going to give us a 9i. Let me check that again. If there's not anything that I've missed, we've got negative 5i plus 4 plus 8i minus 6 plus 6i plus 18. Alright, so that is what we are going to have. Thank you so much for watching.